let's see, I'm still connected here. For this part, oh, so we're gonna start on the chapter. I am gonna stop sharing my screen and share my whiteboard again. Can you guys see my whiteboard?
Yeah.
Okay, so the first thing is standards. Can anybody tell me what a standard is?
Predefined or predefined use, rules and definitions.
Okay, so a way to visualize it, the way I like to visualize it is like blueprints. Okay, and that should help for any type or whatever class you're taking. Standard would be like a sort of blueprints or template. Okay, so organizations, there's an organization that's in charge for creating standards and protocols for networking, for all different devices and how everything communicates on a network, okay? So a standard will be like, for example, if I'm creating a cable, there's a standard on how to create that cable. Let's say a USB cable. They create the standard so that different manufacturers can create the cable similar, and that cable will work with any device that you connect it to, right? If they didn't have the standards, then every manufacturer out there will create their own USB cable, and it would only work with their devices, and that would cause problems, right? So this helps for, the standard helps for all the devices to be able to work together on the same networks, different devices from different manufacturers. So they create the standards, right? Also works for competition between the manufacturers so that they can create, you can buy from different manufacturers. You'll go look for somebody that has a better deal, right? But you expect the USB to work exactly like any other USB when you connect it to the computer. So that's a way to visualize standards. The next one is protocols. What is a protocol?
A rule?
Yes, that's exactly what it is. Your rules of how everything communicates on a network when we're talking about networks, okay? How specifically information travels through that USB. Is it gonna use electricity or it's gonna look, it's gonna use light beams, okay? Whatever it is, there's gonna be rules on how it works, all right? So why is this important? Because everything in networking has standards and has protocols, all right? And this chapter is just an overview of over these things. So let's do an analogy real quick, which I'll probably touch on it on the chapter. When we're trying to send a letter through mailing service, right? Here's my letter. You know what? And first, let's start with the letter itself. What are the standards and protocols that I have to use?
Date.
I'm sorry?
It have an address and a date.
Right. So yeah, let's say my letter, right? I'm sending it to somebody, and one of the standards or protocols that I have to use might be a date. So I have my date here. Right. And then who this letter is gonna be addressed to? Dear someone. Right? Standard rule of thumb, you don't have to follow that standard if you don't want to, right? Then also the person that I'm sending this letter to, I have to send this letter on a language that they can understand, right? So we're talking about communication standards and rules here. There has to be a language. We have to set up a language first. The same thing goes for networking devices. They need to be able to communicate, right? So just on my letter, we already found a few standards. And so what language am I writing? All right, what's another standard that I have to follow? Dear friend, how are you? Quiero poder ir a verte hoy. Oh, sorry. Trying to show something. Konnichiwa. Arigato. And ashituru. So first, there's different languages. So it's not gonna be easy to understand this. Second, there's no spaces. All the words are mashed together, right? When we're writing something, you're gonna make spaces for the different words so it's easily readable, right? You're gonna have different paragraphs. So just on the letter, there's different protocols and standards that we have to follow. Okay, now let's put the letter on the envelope. What kind of standards and protocols do I have to follow when sending this envelope with the letter inside of it?
Address it.
So I need an address, a source address, right? Who is sending it and who's gonna receive it? Destination address. How do I type that address? Can I just put my name and that's it? No, right? I need my physical address for the house. And even that physical address has standards and protocols that I have to follow.
Yeah.
The house of the number for the house, the city, the street name, the city, the state, and the country, right? Same thing for the destination. Then you have a postage stamp on there, which that's gonna have its own standards and protocols. This is what is gonna tell whether it's priority mail or not, right? And once I place it in the mailbox, what's next? So here's one protocol that might be followed or not, right? You have to set that little thing up so that the mailman knows that there's a message or a letter there that needs to be sent somewhere. He's gonna have to follow standards and protocols on what routes he's gonna be following and picking up the mail from, how to organize the mail, where to place the mail. He's also gonna have to follow protocols that have nothing to do with mailing this envelope, right? So following street rules or the street lights and symbols and things like that, which each one of them is gonna have standards and protocols for however they work. Once the mail gets to the USPS, it's gonna be received by someone. That person is gonna bring it to the building, and he's got his own standard and protocols on how to do this. And then somebody's gonna sort it, and they have their own standards and protocols on how to do this, right? I'm just trying to help you visualize, because this concepts on the chapter, it's just going through a whole lot of them, and you're gonna think you need to memorize every single one of them. You don't have to do that right now, okay? Just have an overall idea of what it's happening, okay? They're just rules and standards that these devices have to use to communicate over the network. Right, so next is the OSI layer. The OSI and the TCP/IP layer. So what is this? Does anybody know?
The what?
TCP/IP. Did anybody read the chapter?
Total control.
All right, so what is this? This is just a grouping of the different standards and protocols used in networking so that you can better understand how things communicate on the network. Because this is a concept that's very difficult to understand. This is gonna be easier if you group it and divide it into different groups and then break each group down, okay? So currently we're using TCP/IP suite. This is the model that we're using to communicate on the internet. But we also use the OSI model. That was the first model that was created, but they moved to TCP/IP. But we still go into the OSI model because this further breaks down the different layers or different groups of standards and protocols, okay? So we use OSI model to teach with, but TCP/IP is what's being used for communication on the internet, right? So what is this TCP/IP? This is grouped into different layers. So let's go over the OSI layers and break them down. This might be something you need to memorize. So you have, this is how I memorize these different layers. Please do not throw sausage pizza away. And then we have 7 different layers. Okay. Oh, sorry, it should start from the bottom up. So the physical layer is your first layer. Then you have your data link layer, your network, transport, session, presentation, and application. Okay, and these groups of protocols or this model is used to identify how, let's say, an email travels through the network, starting from the application where you're writing it, all the way traveling through the physical layer, through the cables, to the devices, through the network, and back to another computer and up the different layers again. Okay. During this chapter, if you get really confused while going through the chapter, remember there's just an overview. All you need to know is the difference between standards and protocols, or know what they are, an overview of what they are. And then know that there's different groups or a different model to display these different standards and protocols, the TCP, IP, and OSI models. So just have an overall idea of what they are. All right, so let's have an analogy here. I'm writing an email, right? This is gonna be on the application layer, email, okay? This layer is gonna have protocols and standards that are gonna give services to this software that you're using to write the email. It's gonna give services to the software to be able to communicate on the internet or on the network, okay? So when you hit send, what happens? That email or data packet, all right, is gonna be known as data on the application layer, is gonna be sent to the presentation layer. This layer is in charge of checking or adding. So think of this email is gonna be sent, is gonna be placed on an envelope. That's the best way I can describe it. It's gonna be placed on an envelope. So whatever information is in there, whatever data you're gonna send, that envelope is gonna be sent to the presentation layer. In the presentation layer, you're gonna add labels to it, right? So a label like what type of data is being sent. So if you had a picture on there, you might have something like JPEG as a label, MP4 for video. This is where all your different file formats are gonna be in. If you need to encrypt anything, it's gonna be done on this presentation layer. So I have a label for what type of encryption you're using. If you need to compress the file, which is your file formats, again, they do different compressions. That's gonna be done here on this layer. Once it's done adding all these labels for this layer, then it's gonna place this information in another envelope. This is the way I like to visualize it, okay? So it's gonna go inside another envelope saying it's done, and then pass it to the next layer underneath, okay? Everybody with me so far?
Yep.
Okay, you just need an overall idea of what's going on. On this next layer, you're gonna have different labels on there too. But this layer is in charge of creating a session or starting a session or managing a session or closing a session. What does that mean? So it's gonna communicate with the end device, the device that is gonna receive this mail, and make sure, hey, it's gonna tell it, I'm about to send you something, are you ready? All right, you wanna make sure that you have the attention of the person you're talking to when you're communicating in real life. So right now, I'm asking questions to you, I'm telling you this is what we're about to do, and then I start explaining, right? Same thing with devices. One device is gonna say, hey, I'm about to send you something, are you available to receive it? Or are you ready? Right, so that's what the session, and again, in each one of these layers, there's a lot more going on than what I'm going over. I'm just trying to help you visualize it, and I'm just going over a small portion of what happens, okay? So that happens on the session layer. then this envelope is placed in a different envelope, okay? When this data is moving from one layer to another one is called encapsulation. Write that down. This keyword is what you need to know, this keyword, encapsulation. And so right now, when I'm saying it's going inside another envelope, I'm just helping you visualize how encapsulation works, okay? Or at least a way to be able to remember what encapsulation is. So now it's going to my transport layer. In the transport layer, you're gonna get more labels on this new envelope, right? And something that might go on here is whether the communication is gonna be TCP or UDP. These are protocols that are used to decide how the data is gonna be communicated, all right? If you need it to be reliable, you're gonna be using TCP. So if you're using TCP, that's gonna be a label that is gonna be placed on your transport layer, okay? TCP, and we're gonna go over this again later, but TCP, whenever you use that protocol, the devices are gonna check that the packet arrives to its destination, okay? Another thing that's gonna happen in this layer is that this one letter is gonna be divided into many different segments. So that way it sends small portions of that packet through the network, one piece at a time, and each portion can follow a different path. Remember when we were going over circuit-based networking and we were talking about this? Hopefully you do. But anyway, each one of these pieces is gonna, it could go through a different path depending on how, if the device finds a more reliable path at the time or moment, right? Each one of the segments is gonna be numbered in this layer also. Each one of the segments is gonna have information for it to be able to be routed through the network. So this label here, TCP or UDP, might go in each one of the packets. It might be a label that you will see in each one of the packets, okay? TCP is reliable, meaning that it's gonna check that it arrived. And the other device, if it doesn't arrive, if one of these packets or this pieces, which is a frame, doesn't arrive, let's say number 9, it's gonna communicate with the original device sending the packet and be like, hey, I didn't receive packet number or frame number 9. Can you send it again? And then device number 1 is gonna reply and be like, okay, I will, I'm about to send packet or frame number 9. Here you go. Let me know if you receive it. All right. There's back and forth communication throughout the entire time. This makes this type of communication slower than UDP, but more reliable. UDP, which is used for like video streaming and voice, is not as reliable. It's not checking to see if the other device received the information, but it's faster because it's just sending the information. So all I need to know, UDP is saying, okay, all I need to know is the IP address for the destination. And then as soon as I know the IP address for the destination, all right, I'm sending it out to the physical layer. If it arrives, I don't care. I just know that I have to send it as fast as possible, okay? We're gonna cover this later, right? Once transport layer is done, segmenting, creating the different pieces from this one data packet, right? It's gonna send each one of the pieces to the network layer. And each one of them is gonna be their own individual envelope, okay? In the network layer, one of the jobs of the network layer is to add a source IP address. So who's sending this envelope? And a destination IP address. Who's supposed to receive it? Okay. And then after it has added those labels to the envelope, it's gonna send it to the data link layer. Right? Another thing that you might find in the book is that routers work at the layer 3 network layer. Switches work at data link layer. network cards work at data link layer. Okay, so at the data link layer, data link has sub layers. Okay, one of the layers communicates with layer 3, the networking layer, and the other one works with the physical layer, right? So one of the labels that you might find on here is what type of addressing are you using? Is it IPv4 or IPv6? Another label in my add to it, the actual physical address that is embedded on the network card on the device itself. And if you remember, there's going to be a hexadecimal code. Okay, that's going to go on the label itself. Once the data link is done with this envelope, then it goes to the physical layer, which is in charge of encoding the information. Who can tell me what encoding means? Encoding is whenever you're converting from one technology to another one, or one transmission technology to another one. For example, the computer communicates, or everything on the computer is going to be ones and zeros. Okay, so let's say everything that I've just talked about, all of that is happening in ones and zeros. Okay, but as soon as it gets to a network card, then the network card has to decide, okay, how am I gonna send this to the next device, the device that I'm connected to? Am I connected using a Wi-Fi connection, or is it an Ethernet cable, or is it light emissions that I'm gonna be using, right? And it's gonna convert those ones and zeros into electrical impulses or radio waves or light impulses for fiber optic. Okay, that's one of the jobs of the physical cable, the physical layer. And inside the physical layer, you're gonna find all the actual physical connections and the actual physical devices on the network. Okay, they're gonna be there. All right, so what is the OSI layer good for? What is the TCP/IP layer good for? It helps us understand how everything communicates through the network, and where how the different protocols are grouped together, which is going to help us in turn whenever we're troubleshooting something. Is going to help us troubleshoot. So for example, I can't connect to the network for some reason, right? I could start troubleshooting at that layer 7 application layer, or I could start at the physical layer. What does that mean? So if I go to application layer, first I'm gonna go check that I have an IP address on the computer that I have set up properly, or maybe make sure that it's connecting to DHCP properly. If I wanna start from the top down. If I wanna start from the bottom up, then the first thing I'm going to check is to make sure that the cable is connected to the device itself, and then it's connected to the WA or the other device, the switch, if you're in a local network. Some people use troubleshooting, they'll start at the middle, all right? So more about this later. All right, now, logical addresses. When you hear logical addresses, that's gonna include your IP addresses, 192.168.10.10. This is a virtual address, okay? Something that you're gonna configure, or you're gonna get from the operating system or from DHCP. And then you have physical addresses. This is gonna be talking about the embedded MAC address on every device. Okay, on the network card. The network card has a specific MAC address that should be unique in the entire world, all right? And it tells you exactly what address you have in the local area network. So you'll be using MAC addresses for the local area when communicating in the local area. Switches use this. All right, and when the message is going from one router to another router that is directly connected to it, they're gonna use the MAC address, or it's gonna change as it goes. The IP address is logical. This one stays the same at all times. So for now, do you have any questions? And if you don't understand any of this, that's fine. Hopefully, as we're going through the chapter, this will make sense. If you have to leave at 9, that's okay. If you want to stay while I go through the chapter, you can stay.